today, sometimes they're using different letters for different things. We still have starting amount, right? That's still there, but sometimes they call it A. B is either growth or decay, it's the same thing. So they just use, instead of having to write it twice, they just wrote B. And then sometimes they use X instead of T, but it's the same thing, it's just time, okay? That's all. All right, okay, so let's look at number 1. So what we have to do is build the function. Fill in the blanks there. And then after that, is it growth or decay and how much percent? So kind of like we did the other day, where we had to decide, is it growth or decay based on the R, right? And then we had to go from there. Okay, so first thing. Is it growth or is it decay? By reading the prompt, is it growth? It's growth, right? There's a couple words that actually, it actually says the word grow, okay? It's doubling every 12 years, right? Money, it's money in a bank account. So it's gonna be growth, right? So first thing we're gonna do is we're gonna circle growth. Oops. Right? And then if we grow, are we gonna increase or decrease per year? Increase. Okay? That's for sure. Okay. So now that we know it's growth, we're not gonna look at decay. Decay doesn't exist for this problem. It's just growth. Okay? So what's the first thing that needs to come? Starting amount, right? What's the starting amount going to be for this problem? That's how much they start out with investing, right? So that goes here. Okay. And then we know it's growth, so we know it's going to be 1 plus R, right? Do we know what R is for this? Do we know what the percentage increase is going to be? It's nowhere there, right? It's nowhere there. So we don't know that, so I'm going to leave that blank for now. I'm going to come back to it later, but I'm going to leave that blank for now. And then it's T there, right? T goes there. So to build this, I need one thing. I need to know what the rate is. I know how much it grows, right? They tell me how much it grows, but I need to find what the actual rate is every year. Because if I go to a bank and I say, here's my money, and I ask them, how much is it going to grow? And they're like, you know what? In 12 years, it'll double. And then 12 years after that, it'll double. And I'm like, big deal. I'm not going to keep it 12 years. I only want to keep it a few years, right? I only want to keep it 1 year, 2 years. Can you tell me what percentage? And they're like, they have to be able to tell me, right? So that's why we're going to figure this out. Okay, so we're going to organize our thoughts a little bit. They give us some information, we're just going to organize that. We're going to organize it using a table. Tables are nice because they organize our thoughts. So on one side we have time, right? T. T is years. And on the other side we have F of T. They don't call it Y, but that's what it is, okay? So you can put Y there if you want. You can put F of T if you want. It doesn't matter. It's the same thing. And that's going to be money. How much money is in the bank account? Years and money, okay? So what do I know in terms of years and money? Just by reading the question, what do I know? Every 12 years it's going to double. What did it double from? The starting point, right? And what was the starting amount? So we're going to put 8,800 here. How many years have passed before I get 8,800? How many years have passed before I get 8,800? And nothing has passed. Nothing has passed, right? Okay. And then they say 12 years, right? Every 12 years, what happens? It doubles. So how much is going to be there after 12 years? So use your calculator. Tell me how much is going to be there after 12 years. Braden, Mr. Abrego wanted to see you. Yeah, go ahead. Take your stuff. 17,600 after 12 years. And then another 12 years, I can figure that out too. I think it's 35,200, something like that. $35,200, which is nice to know, but let's say I don't want to keep my money in the bank that long. I want to save for something. I'm saving for something and I don't want to keep it for 12 years. Maybe I only want to keep it for 3 years. They're not going to help me. And I asked them, how much money is going to be in there after 3 years? And they're like, I don't know. That's what we're figuring out, okay, yearly. Okay, so now this is what I know. Every 12 years it doubles, okay? But here's the problem. I don't know what R is. So I'm going to use that to solve for R. So I'm going to usually I use the second one of these. Usually I use that guy. Can you use the first one? I wouldn't use the first one because I already know 8,800. It's already there. You can use the last one, that's okay, but usually I use the middle one. And what do? I plug it in. Because what they have told me is that if I plug in 12 years, I better have $17,600. If I plug in 24 years, I better have $35,200. That has to be true, right? So what I'm going to do is I'm going to take those things that I know and plug it back into my quasi function. It's not a real function yet because I don't know what R is. So instead of f of t, I'm going to use 17,600. $8,800 is the starting amount, so that's always going to stay there. 1 we said plus because we don't know what R is, or it's growth. And then R, we don't know what that is, so I'm going to leave it as R. How many years must that be true? For how many years must that be true? 12. So the power is going to be 12. So in math, if we only have one variable missing, we can solve for it. That's what we're going to do. We're going to solve for R. Our calculator is going to be our best friend for this because there's going to be some things that we don't want to do, calculator can do. Okay, so I got to solve for R. So I'm going to divide both sides. Okay. Okay, so I want to get R by itself. I want R only on this side. Everything else, I want the parentheses gone, I want the power gone, I want the 1 gone, I want the 8,800 gone. But I have to do it in the correct order. So here's my first question. I have parentheses. I have 8,800 right next to the parentheses. Is it okay if I distribute like I've done 1,000 times before? Is that okay if I multiply these guys by 8,800? The answer is no, I can't do that. Even though I've done it 1,000,000 times, there's one difference. Why can't I do it here versus all of the other times that I've done it before? What's different about this problem? What do you think?
The exponent?
The exponent, yeah. For me to be able to do that, this has to be 1. It's not 1. So if it's anything other than 1, I can't distribute. But it's important because what does distribute mean? Adding, subtracting, multiplying, or dividing. Which of those does distribute mean? Multiplying. So it is multiplying. 8,800 is multiplying times the parentheses. It is. But I just can't distribute. So instead, how do I get rid of 8,800? What's the opposite? Division. So I'm going to divide both sides by 8,800. So because I can't distribute, I'm just going to do the opposite to get rid of it. 8,800 divided by 8,800 makes 1. So now I have 1 plus R to the 12th power. And then go to your calculators. What is division over here? What do you get when you divide? 7,600 by 8,800. 2. Sometimes it'll be a whole number, sometimes it'll be a decimal. Whatever it is, we write it. Okay, so now I'm here. So I got rid of the 8,800. Now, can I subtract 1 from both sides to get R by itself? Not yet. I can do that, but not yet. That's going to be my next step. I have to get rid of that power. So what's the opposite of a power? a root. Here's the trick though. The power and the root have to equal the same number for them to cancel out. Like I can't do a square root and a 12, that won't cancel out. So what root do I have to do? 12. Whatever I do to one side, I have to do to the other. So on this side, it just gets rid of the power. On the other side, I have to find the 12th root of 2. That's where your calculator is going to come in handy. Okay, so let's go to the calculator. I'm going to go slow because you got to find a special function here. So get your calculator ready, and I'll show you exactly how to do this. Okay. So you're going to go to, obviously, you're going to go to the calculation, because that's where we always go. We want the 12th root. So I'm not going to use the square root because that's the square root. I don't want the square root. I want the 12th root. So right above that, two buttons above that, it says paste, has a quotation marks, and it has a little like box there, like a little toolbox right below the OK. That's the button we're going to hit. We're going to hit that button there. It gives me more options. It's the toolbox button. I don't want absolute value. That's not what I'm doing here. I want the second one. I want the second one. That will let you pick whatever number you want to pick for the root. That'll let you pick whatever number. This one I want 12. So we got 12. And then 2 on the inside. Okay, so anytime you have a root other than square root, that's where you're going to go on the calculator. It'll allow you to do that. You just have to find that button. Okay, so then you're going to hit enter, and it's a long, ugly decimal. 1.059463094. Here's the thing, though. In the question, it said to round, but that doesn't mean we round every time. That means we round at the end. I'm not done with the problem yet. So I'm going to paste that number onto my, cut and paste that number onto my notes. Okay? So we don't round here. Most of the mistakes I see isn't because you guys don't do it right, it's because of rounding. So it's 1.05. Let's see if I can pull up that number. 946309. So make a little note to yourself, do not round.
You left out
The 4 at the end? Okay. There we go. We will round, but at the end. We're not done with the problem yet. Because this is what happens. This is what happens. Last year I had students do this. They rounded like this. I rounded. They did, but they rounded way too much. And then the next step, it got to a point where they didn't get the right answer because they were rounding too much. Okay? So what I say is don't round until the very end. Okay? And luckily your calculator will memorize that number. Okay? Okay, so let's go back to the problem. How do I get r by itself? What's the last step? -1. -1 whole unit. R equals, luckily my calculator remembers this number. My calculator remembers this number. So you can just cut and paste from your calculator. You can say, I don't think my calculator does remember it. You can say, hey, that number that you just calculated, up, hit enter, -1. That's R. That's what R is going to be. Okay? So when I do that, -1, I get 0.059463094. Now I'm going to round. It says it wants you to round how many spots past the decimal? Before that, though, the sentence before that says how many? 4, I think it says 4 decimal spots. 4 decimal places. So that's where I'm going to go. Okay? So 4 decimal places means 1, 2, 3, 4. That's the guy right there. So that guy can stay at 4, or it can go up to 5. This guy right here says go up to 5. So R is going to be 0.0595. Okay? That's going to be my R. So I'm going to go back to the top and fill in that missing spot, that blank spot that I had. I'm going to fill that in with what R was. Okay? Last step. What percent increases that? I know it's an increase because it's growth. So what percent does that represent? 5.9, right? 5.95. How do I know that? This is how you do it. You take R and you multiply it times 100. Multiply it times 100. And you get 5.95%. And you're done. That's R. That's the percent increase. It's growth. There's my function there. Okay, so we're just building them today. We're building them today. Number 2, you're going to be building. All right. Okay, so let's go. First thing I want you to do with number 2 is it growth with an increase, or is it decay with decrease? That's the first thing I want you to do. Circle those. Read the prompt. Circle those. Which one is it going to be? It's got to be a growth or decay. It's going to be one or the other. So which one is it going to be? Decay. Decreases. Decreases means decay. If it decreases and it's decay, circle both. This one's decreasing by half every 25 years. Okay. All right. What's the starting amount? Do I know what the starting amount? Now I'm not focused on growth, I'm focused on decay. It's going to be 50 grams, right? An isotope is those things that are on the the periodic table in the, in your science room. You have the periodic table. All of those different, those are isotopes. That's what that is. Okay, those die over time. They die over time. This one is dying or decaying or diminishing or depreciating, whatever you want to say. Every 25 years, it's getting cut in half. Its mass, how much is there, is cut in half. Okay? So I know it's going to be 1 minus. Do they give me a percent every year? No, they just say every 25 years it's going to be cut in half. Well, that's great, but I don't have 25 years. I want to know how much in 1 year is it going to decrease. 2 years, 3 years. So we got to figure that out. Okay. What do we do next? What's our next step? Starts with a T. Table. We have T for years. And we have F of T. This is mass. It's not money. It's not people. It's mass. How much is left? Okay, so what do we know? How much did we start with? We started with how much? 50. And then that gets cut in half every 25 years. So that means in 25 years, I'll have 25 mass left. 25 grams, I should say. And then in another 25 years, I'm going to have half of that, which is 12.5. And you could keep going, but that's good enough for our problem. That gives you the idea. It gives you the pattern. I'm dividing by 2 every time. That's all I need. I just need the pattern. Okay? So now I need to use one of those to figure out what R is. So again, I use the middle one. I always use the second one. Do you have to use the second one? No. But that's just what I do. I use the second one. So I'm going to rewrite my function here. So for t, I'm going to put 25, and for f of t, I'm going to put 25. So it's going to be 25 equals 50. 1 minus, I don't know what r is, and that's 25 years. Solve for r. Can I distribute 50? No, because the power is not 1, it's 25. So what do I do first? How do I get r by itself? Divided by 50. What is 25 divided by 50?
25.
Yep, half. 0.5 or half. You can put the decimal, you can put the fraction, whichever one you prefer, as long as you use the correct one, it's okay. Okay. Get rid of the power. How do I get rid of the power? The power, the root has to match the power. If they don't match, they don't cancel out. So we get 25 and 25. So if they match, I could get rid of the root or the power. What is the 25th root of 105? It's going to be a long decimal again. So let's go back to the calculator, and what do you get? It's going to be, let's see, 25 root for 0.5.
0.97.
Yeah. Yeah, so it's going to be 0.92654, 974, 947, sorry, 947. Don't round that number. We'll round it, but not yet. How do I get r by itself? What do I got to do to get r by itself? Subtract 1 from both sides. So I go back to my calculator and I say that long number that you just calculated, can you subtract 1 from it? It's going to give you a negative number. That's not wrong. It's going to give you a negative. Three, 4, 5, 0, 5, 2. If you can't read my handwriting, just look at your calculator. It's right on your calculator. Is that r? That's negative r. Yep, that's negative r. Negative r means negative 1 times r. So how do I get r by itself? Divide by negative 1. The nice thing about dividing by negative 1 is you just makes it positive. Just changes the sign. Okay, that's r. Now you can round it. So how do I round it? Go 4 spaces. 1, 2, 3, 4. So that 3 can stay as a 3, or it can go up to a 4. This one's going to stay. So go back up to your top and fill that blank in that you left earlier. That's your R. 0.0273. Okay. Change that to a or change that to a percent. Which percent is it going to be? 2.73, right? You're going to go that number times 100. And you get 2.73%. Okay. Okay. So number 3 we're going to skip for right now because I want to make sure I have time to do number 4 because number 4 is the more important one. Okay. Number 4 is what you're going to see on like a test because not only do you have to build it, you have to also use it. Why are we building them? Because they're also going to have you use it. That's what number 4 is going to have you do. Okay. All right. So what I want you to do to number 4 is start building. What do you know? What are you missing? So look at number 4. It talks about rabbits. Talks about rabbits. So read the question. What do you know about the question? What do I know? Well, first of all, is it growth or is it decay? Which one is that going to be? It's growth, right? There are more and more and more rabbits, right? It's growing. The rabbits are growing. They started at 6,900 and then they went up to 13,500. So it's growth. So 1 plus. Do we have a starting number of rabbits? 6,900. Do I know how much percent it's going up every year? No. Makes sense. It's kind of the theme of today. We don't know what that R is. So we're going to figure that out. And then I'm going to use it to predict how many rabbits there will be in 2015. Okay. Table. We have T for years. We have Y is rabbits. T is years. Y is rabbits. What do I know?
6,900.
6,900 after how many years? It's in 2005, right? So I can write 2005, you can write that, but I would highly suggest using smaller numbers instead of 2005 and 2012 and 2000. Use smaller numbers. So instead of 2005, what could I say? 0, yeah. Is it? There you go, yeah. Yep. So 2012 will be 7. And 7, there was 13. The reason I suggest that is because when you plug in numbers into your calculator, you want to make them small. Because if you plug in big numbers, it gets really big. It would work if you use 2005 and 2012, but you want to avoid that. And then the question says in 2015. How many years is that? 10. So in 10 years, that's the question here. I got to answer that right there. Well, I would love to be able to plug in 10 and calculate it right now. Problem is I don't know what R is. So I got to find R first, and then I can do that. Okay? So I'm going to do what I've always been doing. Pick the second one, plug it in. 7 years, 13,500 rabbits. So Y is rabbits. And that's after 7 years. What do I do next? Not subtract. You're right. I'm going to do something with 6,900, but not subtract. I'm going to divide. Yeah, I'm going to, because it's multiplication, so I need to divide. So then I'm going to go to my calculator, and I'm going to say, calculator, what is 13,500 divided by 6,900? Okay. What do you get? Sometimes it's a nice, pretty number. Sometimes it's a decimal. I think this one's a decimal. So they give you two options. I think they even give you a fraction option, don't they? You can use either one because it's the same thing. So 13,500 divided by 6,900. You can use, so I had students last period say, which one do you want us to use, the fraction or the long decimal? It doesn't matter to me. It does not matter to me. Personally, I would rather use the fraction because I don't want to have to write all of those numbers and God forbid I get one of them wrong, right? So I'm going to do this one using the fraction. Do you have to use the fraction? No. But I'm going to show you this one using the fraction, 45 over 23, just to show you it's the same exact thing. 45 over 23. What's my next step? A root, right? So this one needs a root, a 7 root. So this side is going to go away, the root and the power. The other side, go back to your calculator, and if you put that in there, it will actually read it. It'll give you a decimal. You just go back and say, hey, I want you to calculate the 7th root of 45 divided by 23. And there's your decimal. My calculator's, I use this for calculus too, so the function's a little different. You guys don't have that one. You guys just have the decimal. 1.100628282. That's the number we want. .1008. Let's see. 6, sorry, 006 2828. What do I do next? Subtract 1. Okay. Is that my answer? Is that how many rabbits there are going to be in 2015? No. So what I have to do is I have to bring down this guy here. 6,900. Now I know what R was. R was 0.10062. Now, how can I use that to figure out how many rabbits I have? This is my function. I built it. So how can I use that to figure out how many rabbits I'm going to have in 2015?
Plug in 10, 15.
Plug in 10. Instead of t, I know 10 years. And y, and it'll tell me how many rabbits. So you plug that into your calculator, and what do you get? Should be like 17,999 point something. Point 1,00628 close parentheses to the. I get 17,999 and 26045. That's where my calculator ends. So we have to round to the nearest whole number. The nearest whole number is this 9 right here. That 2 says stay. So you have 17,299 rabbits in 2015. Or not 2,200, 2,900. Here's the thing, if you put 18,000, it'll mark you wrong. If you put 17,998, it'll mark you wrong. So the best way to figure it out is not to round until the very end. The only time I rounded was here. I didn't round here, I didn't round there, I didn't round there, I didn't round. This is the last. So that's usually where, because I'm telling you right now, tomorrow I'm gonna have a lot of questions. I think you did it right, you just didn't round correctly. So don't round until the end, okay? All right, the other question we'll do later. We'll do it some other time, okay? So tape that into your notes, please.